Okay, here's what we did in geometry today for section 3.4, proving lines are parallel. We had 4 ways to prove that lines are parallel, right? The first way that we showed that lines are parallel is the corresponding angles converse. Basically says if 2 lines are cut by a transversal and those corresponding angles are congruent, well then the 2 lines had to be parallel to begin with. Okay, and that's what the corresponding angles converse says. Then we had 3 theorems about transversals, right? 3.8 said the alternate interior angles converse says this. If you have 2 lines, J and K, and they are cut by a transversal and their alternate interior angles are congruent, well, then the 2 lines have to be parallel to begin with. Okay, so that's what's going on with that one. The consecutive interior angles converse, kind of the same thing, except says this. If you have 2 lines, so J and K, cut by a transversal, here's my transversal over here, and 1 and 2 are consecutive interior angles. If those angles add up to 180 degrees, then again, J and K have to be parallel. So that's the consecutive angles converse. And the third one here, or the fourth one rather, the alternate exterior angles converse, says if you have 2 lines, like I have here, J and K, cut by a transversal, and the exterior angles are congruent, well then the only way that can be possibly true is if J and K are parallel themselves. So those are the things that we started with. Then we had a couple of proofs here, okay, with the following. So prove the following, right? Given that angle 1 is congruent to angle 2, we have to prove that M and N are parallel. So here's how you do it, right? Angle 1 congruent to angle 2, that's the given. Okay, so we check that part off here. So now, 2 and 3 are congruent because they are vertical angles. So therefore 1 is congruent to 3 by transitivity, and notice we have 1 and 3 are congruent. Those are corresponding angles, so therefore M is parallel to N by the corresponding angles converse, which was the first thing that we started in this lesson with. Then we had another one, prove the following here, right? Given that 4 and 5 are supplementary in my drawing here, 4 and 5 are supplementary, prove that G is parallel to N. Okay, so here's how you start it, right? So 4 and 5 are supplementary, that's been given to us. 5 and 6 are supplementary because they are a linear pair, so that's the linear pair postulate. So therefore 4 is congruent to 6 by the congruent supplements theorem. You might want to look that up, that's kind of an interesting one. So therefore if we have 2 angles that are alternate interior and they're congruent, therefore the lines have to be parallel. That is the alternate interior angles converse, okay? So those are the proofs that we did in class. Then there was a U-try. We had everybody break into groups and say, okay, what values of x make J parallel to K? And this, can't really tell what this is here. Oops, let's get that back. Looks like that. And then this was 4x degrees, and this was x degrees over here. So x and 4x are consecutive interior angles, therefore they have to add up to 180. Do a little algebra, and you find that x is equal to 36 degrees. Okay, and there is the homework. All right, you guys, good luck.